Okay, solar sails have been in science fiction for a long time. They are very lightweight, large area mirrors that can reflect sunlight and be accelerated by the photons from the sun, not the solar wind, but the solar flux of photons from the sun. So with clever tricks, they can sail anywhere in the solar system, or even for if lasers are powering them, they could go to distant planets.
This was a snippet from the conversation with science fiction writers and aerospace engineer Guy Immega about his revolutionary idea to use solar sails swarm to fight climate change and making our planet cooler. Cool. I met Guy at When Worlds Collide convention in Calgary. We sat on a few panels together, and now for the entire interview. Welcome to Science Sci-Fi, connecting the public to science and technology. Today we have a special guest, Guy Immega, whom I met at When Worlds Collide Festival, and we had a few panels together. And we are going to talk about solar cells and how to maybe help fix climate change. And this is a topic that I thought will be very interesting to the viewers of this channel. So Guy, can you tell us a little bit about yourself and about the problems you are trying to solve?
My background is in aerospace engineering. I ran a small high-tech company that did autonomous robots for the space station for the Canadian Space Agency. So I have lived and breathed in the aerospace world for many, many years. I became involved with the Planetary Sunshade Foundation, and that foundation is no longer active, but I met a number of people who are both astronauts and engineers interested in climate change and the possibility of using blocking sunlight at L1 to cool the Earth, not just slow global warming, but to actually cool the Earth.
Okay, that's sound pretty cool. Just to make sure the viewers of the channel knows, can you explain a little bit what are solar cells and also what is L1 Lagrange point?
Okay, solar sails have been in science fiction for a long time. They are very lightweight, large area mirrors that can reflect sunlight and be accelerated by the photons from the sun, not the solar wind, but the solar flux of photons from the sun. So with clever tricks, they can sail anywhere in the solar system, or even if lasers are powering them, they could go to distant planets. But what we're talking about is something between the Earth and the sun. So there's plenty of sunlight for solar sails to sail. So L1 is a very special region in space between the Earth and the sun. There's 5 Lagrange points. This is Lagrange point 1. This is effectively where the gravity of Earth and the sun cancel each other, so there is no gravitational pull at that point in space.
Okay, so I know that a Lagrange point is a stable point, relatively stable, so probably need very little propellant in order to move the spacecraft. But since we're talking about solar cell, that's a big surface that it could be affected by solar wind. How are we able to keep the solar cell at one point, assuming it is blocking the sun?
There are many schemes for placing and keeping solar sails or shaders in the L1 position. There are many schemes for doing this. My particular take on this is that solar sails can be used in what they call a station-keeping Lissajous orbit. So they would constantly move around like a swarm of butterflies in the L1 position. They would be not locked in position. Other schemes show big panels tied together and locked together, and there are various ideas about how to manage this. But I believe that having them mobile and flying around in L1 is a better way to go.
Yeah, I think so too, because if it's stationary, stay on the same spot, then it's probably needs some kind of propeller in order to push itself back after it's being pushed by the solar wind.
One big advantage to these solar sails that I'm thinking about is that if they're in a relatively high Earth orbit, but not geosynchronous, they can navigate by themselves all the way to L1. They don't need a rocket to push themselves there. You can just instruct them to go there, and if they have sufficient navigation capability, they will fly to L1 on their own. It will take months, but so what?
Yeah, that's actually a cool idea. So basically, we just need enough to bring them to orbit. But once they are
Not
in
too
orbit,
low in orbit, because of course, low Earth orbit, where the space station is, for example, there's still a thin atmosphere. And that atmosphere is enough to interfere with a solar sail. You need thinner, more perfect vacuum for them to operate properly in space.
I know the International Space Station is about 350 kilometers above ground, or 400 kilometers.
That's right, and they have to constantly elevate the
Boost.
space station. They use rockets to boost it up in a higher altitude because it is slowing down. And if that isn't done, of course, it will crash into the atmosphere and burn up.
Okay, so do you want to get a little bit more into climate science and what is the problem we currently have of global warming is that we have a body in space that absorb radiation from the sun and emit radiation as mostly infrared. But as we emit, as there are more greenhouse gases, the planet is warming. So basically the idea is to cool it down by blocking some small percentage of the radiation that comes from the sun.
You said it very well, Ron. Other schemes are necessary too. I strongly believe that we need to limit burning of carbon. We need to carbon capture if possible. We need to conserve energy. We need to do everything we can because the problem is only growing and it will continue to grow. Even if we were to totally stop burning coal today, it would still grow.
Yeah, that's true. That's what most scientists are saying. Let's see, what's the next question? What materials are you going to use for the sail itself?
Well, the solar sails traditionally have had very thin membranes. I advocate the use of a membrane called Kapton. This is used as a membrane for the Webb Space Telescope. There are, I believe, 7 layers of Kapton, which are reflective coatings on them, because the James Webb Space Telescope must be kept extremely cold. And so all the sunlight hitting that telescope is reflected by these layers of Kapton, which is a space-rated membrane. There are other possibilities, but that is the one that I think is probably the most suited. It can be very thin. There are various thicknesses of it. You can buy this material in quantity for various purposes. It's used in electronic assembly. You can print printed circuits on it. Your cell phone has lots of Kapton membranes in it for connectors and for various components.
Okay, so if we have in the email you said that in order to send, you probably need either a very, very, very large solar cell that means a construction that is not sure if it's feasible at the technology we have today, or set a swarm of a lot of relatively small. So how small are we talking about, and how are we going to launch them into?
All right. Well, my conception here is that many small solar sails are much better than a few larger solar sails. We know that they won't last forever, and as they fail, they'll be blown out of the solar system. They won't be a problem, but a large swarm or flock of small solar sails, I envisage these to be 1 or 2 or 3 meters in diameter, not hundreds of meters like some people are talking about with other solar sails. These small circular solar sails would not have any structure to them. They would be slowly spinning to keep them flat, and on their surface, printed circuits would be there to make power from solar energy, would have radios, and would be able to vector sunlight away from the surface in different directions to steer the solar sail.
Okay. How are this technology are going to help, for example, ocean? So the solution, I understand it, it's going to block some of the sunlight that's going to cool the earth and counter the greenhouse gases that are rising in the temperature, but it will not solve, for example, issue like ocean acidification and what happened in the coral reef when a lot of CO2 is absorbed into the ocean. So it's not a total solution.
It is not a
Right.
total solution. It will help the coral reefs because one thing that's hurting the coral reefs is ocean temperature. So we can cool the ocean this way as well as cooling the surface of the earth, but it will not remove carbon dioxide from the atmosphere. And ocean acidification is a result of carbon dioxide from the atmosphere being absorbed in seawater.
And what is the timeline we are talking about?
Well,
Until
I'd
we
love
have
to see a proof of concept in a decade, but that's my optimistic idea. That means that somebody really thinks this is a good idea and will fund it. Right now, there is no particular momentum in that direction, so I don't know when it would really happen.
you think collaborating maybe with the Canadian Space Agency?
Well, I would love to do that, but they don't have a budget for this, and they're very tight with their money. I have long experience with them, and I don't expect them to lead the charge. It would be the European Space Agency most likely, and maybe they could persuade NASA, but I don't think the Canadian Space Agency will take the lead.
That's actually bad news, I would say. And what about the private sector? Private sector probably need the profit. So
I believe the private sector could participate. This is a question of funding because also with technology development, many contractors would love to have a contract to develop various pieces of this technology. But the big issue is private sector funding. And my one big idea on this, and this is not by any means certain, is that there is a reinsurance industry. You know about insurance. You have insurance on your house, and if there's a disaster, then you would collect some money and fix your house. But there's also an industry that insures the insurers called a reinsurance industry. So all of the umbrella group of insurers are insured by the reinsurance industry. It's a major player in the global economy. It's in their interests to limit damage by climate change. You know, we just saw the devastation in Hawaii, and this is going to be paid for by somebody's insurance.
Yeah, you read the
part.
Yeah, you're absolutely correct. I saw some articles that not article research done by economics. I have an economics degree in my background. So they estimated, I think even if we are reduced to only 1.5 degrees by the end of the century, it will cause a damage that is equivalent to something like 4% of the GDP, which is, by then it's going to be many trillions of dollars. So if we can invest a smaller amount of that in order to mitigate, then it could be economical to do that, even if there is no direct income to the company who launched those.
I totally agree. I think it's possible to get support, political support, and financial support from various sectors that are at risk because of global warming.
Okay, so what is the timeline and the cost? Do you think such a system will cost?
Well, I've written this up with estimates in my my website, www.planet-cooling.com. I think for a few millions of dollars, we could do a proof of concept, which is about as far as I've gone in detail, because this is a very, very big mega project. However, if it works well and if we can mass produce these tiny solar sails, I call them pico sails, just to emphasize their small size compared to the normal idea of a solar sail. Then we need a way to put them in L1, get them in orbit. And most people would like to launch all this and manufacture all this in space, perhaps on the moon. And I totally agree, that's a great idea, but we are very far from having enough industrial infrastructure on the moon to do manufacturing and launch from the moon. So we're left with, if we're in a hurry, and I believe we are in an urgent situation, we must launch from Earth. And so I've tried to conceptualize and outline what I call a mass launch system, where rockets are launched every 5 minutes, 24 hours a day for 20 years to get enough pico solar sails in L1 to do a job. This is a very big, ambitious project, and it's
Every
hard to
5
know
minutes.
exactly how much it will cost. It depends a lot on how reusable the rockets are.
And I know that SpaceX is working on reusable rockets, and they are the most optimistic scenario they have is that the rocket could be launched 3 times a day, something like that. So once every 5 minutes, that seems very, very aggressive. I know there are other systems that maybe you, I don't know. And I know that I remember that you were talking about space elevator. We probably don't have material strong enough for space elevator, but there are other solutions like maybe some kind of a railgun. In some of my science fiction story, I wrote a story about a railgun that going in the Kilimanjaro 300 kilometers. So it can launch payload if you're willing to go more than 10G acceleration. It can launch payload to maybe at a much lower cost and a higher frequency than rockets.
I would love to see a railgun or some alternative launch method. I don't like rockets. I only know that rockets are well proven. The launch rates that SpaceX is talking about is for their giant Starship, and I really like the Raptor 2 rocket engine from SpaceX. I think it's a brilliant engine. They talk about thousands of times for reuse in the future. So I would like to use a smaller rocket with fewer engines and more of them. There's an optimal size for relaunch, and getting the rocket prepared and relaunched. These very giant rockets that Elon Musk is talking about going to Mars with take time to set up. They have to stack stages. They have to do a number of things which are time consuming. Even fueling such a large rocket takes many hours. So it would take a lot of those big rockets. It's possible the big rockets are more efficient. I conceptualized using the Raptor 2 engine from SpaceX in a smaller rocket, and it's just one possible choice. It's outlined in my website.
Probably have to be more than one stage, 2 or more.
It does, but it doesn't have to be. At 2 stages can do it. You can't do a single stage to orbit efficiently. So it will be a 2-stage rocket based on the Raptor 2 engine, which I think is an excellent, excellent rocket engine. I think it's the best rocket engine on the planet, but maybe they'll have a better one soon. It is a methane burning engine, and if it goes through the stratosphere, there will be some carbon dioxide deposited in the stratosphere along with water vapor. It turns out that water vapor is a bad greenhouse gas in the stratosphere too, so it's unclear what the impact of all this will be. This is a topic that needs a lot of further study.
Yeah, I know that the engine was saying that eventually he envisioned it to be carbon neutral because they will generate the methane from water and atmospheric CO2 and solar panels with the Sebastian reactor. So to make it but you're right that it will omit some of it in the upper atmosphere, in the ionosphere.
Well, even a hydrolox rocket, like the Delta rockets, which are only burn hydrogen, or even the shuttle main engines only burn hydrogen. They produce only water vapor, but in terms of greenhouse gases in the stratosphere, water vapor is a bad one.
Yeah, and water, actually, hydrogen could be a little bit more efficient than
It is a
the
little more efficient, but it's more difficult to use. It's a
store.
trade-off. The methane engines are well developed now with SpaceX. Methane will produce some CO2 and some water vapor in the stratosphere. And so it may be, as I can't fully determine now, but I believe that the methane, the carbon dioxide from burning methane in the stratosphere may be less of a greenhouse gas than the water vapor in the stratosphere. It's an open debate. I haven't got firm figures on this yet.
And is there some kind of circulation that may bring the CO2 down to the closer to the surface?
I can't answer that. I don't know enough about that.
Okay, they want to talk about building on the moon. I know this is a bit more complex, but the big advantage that the moon has is, I would say, the lower gravity. So launching from, and there in the moon, there is no carbon, so it basically has to be hydrogen if you want to launch for the moon. But also being a rail gun, like if you read Robert
Well, the rail gun is that kind of electromagnetic launch on the moon is the right way to go. You're going to have endless solar power on the moon. You can launch from the moon because it's 1/6 gravity of Earth. It's an ideal place to do this. I would be strongly advocating it if I believe that the lunar industrial infrastructure would be available in time.
And that way, if I try to go into the more gloomier science fiction scenario, in some movies and TV series, trying to resolve climate change by blocking the sun caused the opposite effect, global freezing. But the book Snowpiercer is one example of that. So how can you, how reversible it is?
Well, this is an interesting proposition with these pico sails. There are two things you can do. The sail is small enough to be agile and change attitude. In other words, tip. And so it can tip edge on to the sun, like you have Venetian blinds in a window, and you can rotate the blind so that it lets sunlight in or blocks sunlight, so that the sails can be in minutes. They can tip edgewise and let more sun in, or tip fully blocking and let less sunlight in. Also, they can sail away from L1. If you have too many of them, which is unlikely for the long while, you can take them out of position and let them do station keeping near L1. They don't need to be there all the time. So they're very, very programmable. They're very adjustable. And I believe, for instance, that one of the things we may want to do is cool the Pacific Ocean, but let the land have more sunlight because of agricultural production. So it should be possible, as the Earth rotates in its daily rotation, at one point, the Pacific Ocean is facing the sun, and it's practically the whole face of the Earth toward the sun. That's when you'd cool the ocean and let the lands have sunlight so you can grow more crops.
And how do we make sure that we are not going to harm the plankton or marine life that also needs sunlight?
Well, it's not like it would be totally dark. We're talking about much less than 1%. We're talking about dust on a light bulb. So if you have a light bulb in your room and there's a little bit of dust on it, the light is still shining. Okay. It's not like there will be darkness.
Yeah, we have a few more minutes. Do you want to talk about other things that we can use the pico sails for? For example, I was thinking maybe generate energy and beam them to Earth or some of the space station that we're going to have?
That's an interesting question. I have at the moment tried to simplify the design. It is difficult to have the ability to transmit energy from the sail buy, for instance, microwaves to Earth, you need a lot more infrastructure on the sail itself, a lot more weight. Right, my conception right now is that the sail has almost no payload. It has printed circuits on its surface for a radio receiver, for little vector, light vector mirrors, and for antennas and so on. But if you want to be able to gather solar power and use microwaves to beam it down to Earth, then you need a completely different infrastructure. Because the microwave transmitter is not simple and it's not lightweight. You can't have something that's going to go all the way to Earth as a surface mount component on these solar sails. So I have avoided talking about dual use sails. Somebody may figure this out. It's a really great idea to have solar power from space. And I know there are a number of well-funded efforts looking at this, and I wish them well.
Yeah, I know there is a Japanese program, but those are talking about the huge satellites in geosynchronous orbit that transmit a microwave to one point on Earth. They're not in, but
no, they need to be able to focus the signal on a microwave receiver area, perhaps in a desert. And this is perhaps a geosynchronous satellite problem, but then there's a question of availability of sunlight during the orbit. So all of these things have trade-offs. I have not analyzed in detail solar power proposals. As I say, I've just tried to focus on managing global warming or global cooling. This is a simple idea, and maybe they can be combined, but I haven't seen a good way to do that yet.
do you have an estimation how much such a system would cost?
For the mirrors?
No,
I
not
mean,
the mirror, for the whole solar pico solar sail array with the launching capability, everything.
I do have some cost estimates in my website. They are very rough. I hope that the mass launch system can achieve less than $1 per kilogram. That's a US dollar per kilogram. I believe that's an achievable goal for launch mass, payload mass.
It's 100% reusable.
Well, yes, the rocket itself is 100% reusable. And one conception here is that the first stage will land much like SpaceX's boosters do now. They would come back and sit down on their tail. The other part of it, which goes to orbit, would be like a space plane and would land on a runway. But yes, I want to make it must be both stages must be 100% reusable and instantly recyclable. Of course, they need to be inspected and set up again for launch. And the mass launch system description shows a way to do this. It is more science fiction now than science fact. I'm a science fiction writer, so it's fun and interesting for me to imagine how to get this done. But this is not a dramatic novel. It's an engineering concept.
Okay, so we are almost out of time. Is there any topic you would like to add before we wrap things up?
I'd like to comment on what they call the moral hazard problem, which is if we actually demonstrate global cooling, then people will feel free to burn more coal. This is a terrible, terrible mistake. That's the moral hazard of this project. Many people are worried about this, and I believe that we need to do both reduction of burning CO2 or burning coal or burning carbon and global cooling. We need every trick in the book in order to stave off a big climate disaster. So the moral hazard problem is one that needs to be directly addressed as if we're going to promote this idea.
Yeah, I know that climate change, it of course have a lot more bad than good, but it has some good aspects. CO2 in the atmosphere can help photosynthesis if it's not too high.
It is a fertilizer for crops.
Yeah, but so we are talking basically about upgrading Earth, but we want to make sure we don't go too out of balance.
I believe that if humanity lasts another 1,000 years, we will have global climate control. I believe that's inevitable.
Okay. Yeah, I think so too. We can upgrade the Earth and engineer some kind of a solution, and this idea could work, at least in concept. So, where can people find you, and where they can find your books?
My book is now out in from Edge Publishing. The name of my science fiction book is Super Earth Mother. It shows a way to colonize distant exoplanets using artificial intelligence. So Super Earth Mother, Amazon.com, or whatever bookstore you might look at. Edge Publishing will also sell you books. And I'm delighted if you will look at that. And I'm very happy that my science fiction novel is finally in print.
Yeah, and I'll put it in the links in the description. So thank you very much, and I'll put all the links as we talked about. And I hope to see you in other conventions and in the future.
Okay, yes, I hope we see you again, Ron. And the website for the global cooling is www.planet-cooling.com.
Okay, I'll make sure to add this as well. So
Thank you,
very much.
Ron. Good luck.
Thank you.